Hi friends, welcome to SR Physics Academy. Today we are going to discuss about spectroscopy. Some key points are there. What is monochromatic light, polychromatic light, spectrometer, scattering of light, dispersion of light. So these are the points we are using in our videos. So in first one, introduction, what is spectroscopy? Okay. The spectroscopy is the interaction of electromagnetic radiation with the matter. Spectroscopy is the learning and examination, emission and absorption spectra associated with an atom to determine its properties. Okay, so we know that spectroscopy is a study of interaction between matter and electromagnetic radiation as a what function of wavelength and frequency of the radiation. Even we can determine the structure of organic and inorganic compound using this. Okay, that is spectroscopy. Even spectroscopy is used as a tool for studying the structure of atoms and molecules. If we are getting the large number of wavelength, okay, emitted, so what we will get? Proper their structural in detail we can study. In chemistry, we are using the spectroscopy help to study or analyze various chemical components or elements. Even physics, it help to determine the atmosphere of planets. Okay. Next, we will study about what is electromagnetic radiation. Okay. Electromagnetic radiation means electromagnetic radiation is a form of energy that propagates as both electric and magnetic waves. In this electromagnetic waves, how we are getting electric and magnetic means electromagnetic waves are created due to what? Periodic change of electric and magnetic fields. In this one, electromagnetic means we are getting electric and magnetic disturbance traveling through the space at the speed of what? 3 into 10 power 8 meter per second. It contains neither or nor charge but travel in packet of radiant energy is we can say that photon or quanta. Another name is quanta. There is a spectrum of electromagnetic radiation. So how we are getting the electromagnetic radiation is made of radio waves, infrared waves, okay, and microwaves, infrared, ultraviolet, gamma rays and X-ray rays. Even some source of electromagnetic radiation include source in the cosmos, we know the sun and star, radioactive elements and manufactured device. So here an arranged array of electromagnetic radiation in the sequence of their wavelength or frequency. Okay, so in this one we can see that electromagnetic spectrum how we are getting here. First one is a radio wave. Some order it should be there. Okay. First I am written here are radio wave, microwaves, infrared, ultraviolet is there, and gamma rays, then X-ray rays. So RMIUGX. This is the order. Okay. How it is the order we are getting means an arranged array of electromagnetic radiation in the sequence of their wavelength or frequency. So either you have to means there we can't change the sequence. Okay, either don't write it here gamma first and micro second, third, like this is the order because according to their wavelength. So we can say RMIUGX. Okay, RMIUGX. Is clear now? Now, In this one, suppose increasing frequency and wavelength is there. Suppose in the increasing wavelength, what happened means frequency, it will be decreasing. That is the order is there. So this is the spectrum. What we discuss here, this or the particular wavelength is there: radio, micro, infra, visible, ultra, X-ray, and gamma rays. Next, in this one, wavelength and frequency. In this case, you observe this diagram. What did you understand? Means wavelength and frequency are inversely proportional. Suppose either increasing your wavelength, then decreasing frequency. Now these are 10 power 3, 10 power 2, 10 power minus 5. These are the particular wavelength in meter. So there it is. The radio means the particular, this within the range. There's a particular wavelength region is there. So we have, in order to wavelength, we will get the wavelength also and frequency region. Next, we will discuss what is interaction of electromagnetic radiation with the matter. Okay. So in the last class, means last video, I discussed about that how what is absorption and emission. So in this one, how any matter, how the electromagnetic radiation interact with the matter. So in this one, I am taking here any matter is there. So here incident ray, okay. This incident ray, we know that when it is interact with the matter, what happen? Either absorb or emission. That we discussed, okay, in the spectrum. But some cases, okay, some of the frequency, what happen? It is scattering, okay. Some frequencies are scattering. So here this matters are scattering. So in this case, whether the incident ray frequency and the scattering, here incident frequency I am writing nu 0 and scattering means nu s, s means scattering. So in this case, incident frequency and scattering frequency both are equal, then we can say that it is a Rayleigh scattering. Clear now? What is Rayleigh scattering? The incident frequency and scattering frequency, both frequencies are equal, then we can say nu s equal to nu 0 or nu 0 equal to nu s, both are equal. But in some case, what happens? It is not equal. Okay, incident ray is not equal to scattering frequency. Then we can say Raman scattering. That means nu s not equal to nu 0. What is the meaning of nu s equal to nu 0? Means both the incident and scattering values are same. But in this nu s and not scattering and incident ray both are not equal. So in this case, there are Raman scattering also two types are there. There it is Stokes lines and anti-Stokes line. In this Stokes line, whether the incident ray is more and scattering is less, then we can say Stokes line. Suppose here frequency, there it is, we are getting 40 or sorry, okay, 40 we are taking some value 40. In this case, scattering we are getting Stokes, according to Stokes we will get less value. Less value means maybe we will get 20. Okay. So that radiation, so it is not equal also, even the incident ray is more, then we can say Stokes lines. This opposite Stokes lines, we can say that it is an anti-Stokes lines. What did you understand here? There it is, scattering is more and incident is less. Okay, incident frequency is less, then we can say anti-Stokes line. Is it clear? Okay, once more I am explaining. When the electromagnetic radiation interact with the matter, some absorption and emission is there, but in some radiations are scattering. So when incident ray frequency and scattering ray frequency both are equal, then we can say Rayleigh scattering. Next is when incident ray not equal to scattering, then Raman scattering. This Raman scattering, suppose incident ray is more compared to scattering, then we can say Stokes line. Clear? Now, incident ray is less and scattering is more frequency, then we can say anti-Stokes line. Let's go to next. So, according to this diagram, what did you understand? Relay scattering is there, Stokes and anti-Stokes. But look at this, these arrows. What did you understand? In this case, since we will go back our last means video. We know that what is absorption? Here some electron or some matters are there, interact with the electromagnetic radiation. What will happen? This ground state electrons are getting, that means one level, zero level. Here zero I am taking. Last video I am taken E0, E1, E2, that different energy level. So in this level, ground state level, these energies are before stable. When they interact with the matters or electrons, so these matter electrons are getting some disturbance or unstable, so it will start to jump from lower energy. So see, if we are getting more energy, so it will start to jump, okay, another place. Is it clear? So that when it will be absorb some radiation, then we can say that it is an absorption. This is we call as some absorb photon energies are there. Okay, it will be absorb means on radiations there. Next is that is H nu, photon energy. Even again it will jump from what is that high level to lower level, then we can, so that time also it emits some radiation. That radiation we call, that is we said emission. So now you know that what is absorption, what is emission. Same also here, when the incident ray, this is we can say that this incident ray, here which point we have taken, suppose ground is 0. So 0 it jump to level, a higher level, then again same electron it jump from higher to down, okay, lower level, it is the same point. Okay, suppose I can say the example, you are going from home to school, and then again school to home, that means from wherever you are going, then same place only coming back. So that means we can say it is a Rayleigh scattering. That means incident frequency and scattering frequency both are equal. Now, in this Stokes line, already we know the Raman scattering, there it is incident and incident ray frequency and scattering frequency, it is not equal. So that is very clear. It is not, it is whenever it is going the electron, it is not coming to same state. But in this case, it is not equal. So that means from incident ray is more from 0 to upper level. Then here what happened? Then upper level 2, it is coming to the energy level 1 has come, because the here whenever it is coming, what happened? This energy is stable. One state only it is stable, or the electrons. Okay. So that means their incident ray is more, incident frequency is more and scattering is less compared to wherever the going point and okay, return point. So this is, we can say that Stokes Raman. That means incident is more and scattering is less. But in this case, but here what happened? The jumping from 0 level. Okay, 0 level means what? So from this energy level, it is one is that electron, one energy level is happy, stable, but it is getting some more means disturbance or some more energy. So it jump to upper level, but after that it is coming back scattering. What will happen? It is coming to again extreme zero level. Zero level means that is another that the ground state it has come. Okay, so in this case what happened? What did you understand? Incident frequency is less and scattering frequency is more. See there, this distance is there, is it? So this is, we can say that anti-Stokes length. Clear? Now, so from this electromagnetic spectrum, we have to learn some steps, then only we can calculate type of molecular energy. Okay, so already we know that, just I am giving one more name. So in this case, microwave. Microwave, another name we can say that rotational spectroscopy or rotational transition. Clear? Rotation is there. Microwave, another name is rotation. Next is here infrared. Okay, infrared means what? Vibrational energy. This infrared also they are near IR, mid IR and far IR. That is a different their region they are putting. So this is also vibrational spectroscopy or vibrational transition. Even visible and ultraviolet, we can say that electronic spectroscopy or electronic transition region. Okay. So in your means for exam means entrance exam also they won't ask you directly microwave, they will ask you rotational spectra, rotational value like that. Okay. Even vibrational and electronic transition region. So you should know the name. Even one more name it is there, that is a radioscopy. That means we can say that NMR spectroscopy. Okay, what do you call? NMR. Next is here. Now we will learn we have to how to calculate the total molecular energy. Okay, so molecular structure or molecular energy. So there are type of us, we should know the molecular energy types. First one is we know that microwave. What is that here? Sorry. Okay, even rotational energy is there, vibrational energy is there, and electronic energy and transitional energy is there. Okay, so in this case, the how to calculate the total energy means the all four energy we are adding together. Okay, then we will get translational. But in this case, this translational energy is purely kinetic and non-condensate. Okay, the form of energy. So we will neglect this translational energy. Then we will get the total energy is, what is that? Electric energy is there, vibrational energy is there, rotational energy. So these electric, vibrational, rotational we will discuss later on. Okay, now it's clear how to calculate the total energy means we have to sum of these energies. Clear? Okay. Hope you are understanding. Thanks for watching.